Hello everyone. Today we'll solve Leetcode 1647, which is minimum deletion to make character frequencies unique. So I'll explain the problem with example. So what we need to do is we have given a string, and what we can do, we can delete characters from this string in such a way that frequency of each character become unique. For example, in this case, frequency of A is 3, frequency of B is 3, frequency of C is 2. In this case, if you see, frequency of A and B both are equal. So what we can do is we have to delete some character from here. Let's try to delete A first. If you delete A, then frequency of A will become 2, B will become 3, and C is again 2. Again, if you see frequency of A and C both are equal, then we have to delete one character. Let's again delete A only. Then frequency of A will become 1, B will become 3, C will become 2. Now if you see, frequency of each character is unique. So now how many deletion we did? 2 times A, right? So answer for this question is A. So we have to delete characters in such a way that number of deletion has to be minimum. Okay, let's think of some solution. So if you see, what we are concerned with, the frequency of each characters, not with the actual string and the order of a string and how the string looks like. We only concerned with the frequencies. So from now on, I'm not going to write the string, I'll only write the frequency of each character. If you see, we have to decrease the frequency whenever there is repetition. In this case, frequency was something like 332. So if you see till here, it's unique. If you reach at this index, then there is a repetition. Then we have to decrease this frequency. So how we can minimize it is we have to decrease minimum number of steps. So for example, from 3, where I can decrease, let's say from 3 either we can decrease to 2, but 2 is already present, then we have to decrease again, which has to be reached. So it is also possible that we can delete this complete 3 at all. Then in that case, it will require 3 deletion, right? But we have to delete minimum as possible. So simple approach is, what we can do is we count the frequency of each character and then save it into a string, into an array, and then try to delete characters from it. It means that try to decrement once there is repetition. So what we can do is simply, let's take simple example. Let's say there is a frequency of 5, 5. Let's say there is a 4 and 4. Then what we can do is from 5, again 5 comes, then it's a repetition, and then we have to decrease it. So where all we can decrease, let's try for 4, or let's try for 4 which is already there, so we have to go with 3. Then again 4 comes, then again 3 comes, again 4 again. Then we can't go with 3, we have to go with 2 here. So here number of deletion is 2. I'll write with other, okay. Here 5 minus 3 which is 2, and here 4 minus 2 which is 2. So number of deletion required in this case is 4. So I wanted to see one pattern over here. Just see what is the final number we see. This will be 5, 3, 4, 2, which is 2, 3, 4, 5. And original number was 5, 5, 4, 4. So if you want to see what is the number of deletion we did, it will be 5 plus 5 plus 4 plus 4. This was the original number. From here we deleted some number such that we form the another set of number, which is 2, 3 plus 4 plus 5. Then it comes out to be 4. So if you see, either way you can do, like the other options would be what? Instead of processing from left to right, let's say if I process from right to left, then what would be the number of deletion and what would be the set of numbers we form after that. Till here unique. Once we reach here, yes, it's duplicate, we have to convert it, and what is the number which are available, which is 3, and next 5 is unique, then again 5 comes, then again you have to delete till 2. Okay, then again set of numbers is 2, 5, 3 and 4. If you see, again we found the same number. So either way you can process. If you always follow the rule that we have to delete as minimum as possible, the final set of numbers you get, which will be unique, then order doesn't matter. So either way you can do, you'll get the same number of deletion. What we can do is, first store the frequency, store all the frequency in some array. And next step will be create one hash, and then we have to traverse this frequency array, and when there is a repetition, then try to find which number we can replace it with. For example, let's say once 5 is there in the hash, again 5 comes, then see which number we can replace it. How we can try for 4. If 4 is there in the hash, it's fine. We can't do that. If 4 is not there, move it to the 4. Again when 4 comes, then 4 is already there, then try for 3, convert it into 3. Again 4 comes, then see, try for 3 is already there, then it will be 2. Then again if you see the setup number, which will be 5, 4, 3, 2. So this way we will be able to get the final answer. Let's think about time and space complexity in this case. So in time complexity, if you see, the first step is taking just traversing complete string and saving into some array, which is taking n time, and then where n is the length of a string, and then we are creating a hash, and now we are traversing this new array, which will be depend on how many unique characters we have. So if let's say we have k characters, then in this k character what we are doing is we are traversing this array and trying to replace the number with some other number. So in this step, it's not a order of one operation. Let me show you. So from 5, it might be we'll try for 4, it might be possible we'll try for 3, and again we'll try for 2, and then we'll try for. So it's not a O of 1 step. It might take longer time. So how much max time it will take? So for that, just think of we have some frequency array which looks like something like this. Then what will happen here? So now this 5 will be unique, and then this 5 will be replaced with 4, this 5 will replace with 3, this 5 will replace with 2, this 5 will replace with 1. So think about number of steps in term of, let's say k is the total number of unique characters we have. Then here if you see number of operations would be something like k minus 1. If this one is the k, then this will be something like k minus 2 dot here will be 0. So if you see, this will be some kind of AP, and sum of this would be in order of k square. So the frequency here, the time complexity would be O of n plus k square. Just think about the space complexity. So what we are doing is we are creating a hash and this extra array. So this extra array will be the size of k, and this hash will also be a size of k, because we are anyway saving the numbers which will be in hash. Basically the frequency, let's say k is the total unique numbers we have. So for corresponding to each number we'll have some frequency. So what are the different frequencies which have? So if we have total k unique number, and we have total n characters, so one character might have frequency till n. So in hash we might end up saving the n number. So the space complexity will be O of n. Let's think of some other solution. As the order of processing the element doesn't matter, so what we can do is we can create a max heap, and when there is a repetition, we'll try to decrease a number and add it into the heap. So what would be the solution here? We add all the element to the heap, all the element to heap, and next step would be we'll remove one element from heap and then try to match that element with the topmost element of the heap. So if both the elements are matching, then in that case, what are the options? We have to decrease any of that number. So what we can do is, whatever number we remove from the heap, we decrease that number. Let's say there is the same example. If you see, there will be 5 5 4 4. This will be the element present in the heap. If you remove one element, let's say 5 will be removed because it's the max heap, then 5 will be that element we removed, and now topmost element will be 4. If you compare both of them, then it comes out to be same. Then what we can do is we decrease this number by 1, then this will become 4, and 4 will again be added into the heap. So now new content of heap will be 5 4 4 and 4. Now next step will be we again remove top one element from here, then 5 will be removed and compare with the topmost element. It's not same, right? Then it's okay because it's unique now. Then again next step will be remove one element from here, then 4 will be removed and compare with topmost element, which is same. Then you have to decrease it, add it into the heap. Then the new element would be, then again we'll remove one element which is 4, compare with topmost element which is equal, then again it will be 3, added into the heap. Then next will be 4 3 3, removed one element, 4, match with the topmost element, not same, it will be removed, new content will be 3 and 3. Then again here one step will be removed, so it will be added to 1, and now 3 will remove 3 from here, compare with topmost element which is same, then decrease to 1, then there will be 1 steps, then 2 will be added, then content will be 3 comma 2, and then remove topmost element, compare with topmost now which is not equivalent, 3 will be removed, again element will be 2, it will be removed, no other element, so no other relation. So total number of deletion in this case comes out to be 4. So let's think about time and space complexity in this solution. So what's going on? So first step is storing the element into the storing count of each character, frequency of each character takes n time, and then next what we are doing is we are picking an element and decreasing it if it is matching with topmost element and adding back to the heap. So how many times we need to do? As in the last example I showed you, that it might possible that for a particular number we end up decreasing to 0, 4 3 2 1 0, and it will happen when frequency of all the numbers are same. So in this case total k square order will be there. In k square times we have to decrease the number. Then decreasing a number and adding it into the queue, adding again into the heap will take log of k time. So this will be the time complexity in this case. And what would be the space complexity? For space complexity, again there we are having a heap. So what would be the size of heap? So this will store the frequency of each character. So how many characters we have? K, so it will be O of k. So if you see in all the above approaches, what we are doing is we are trying to reduce the number one step at a time. For example, 5 5 4 4. If there is a repetition over here, what we are doing is we are trying for 4. And if again there is a repetition, we'll try for 3, something like that. So instead of doing that, if you know that how many deletions this 5 needed to make it unique, let's say if you make to 3, it will be unique. If you know beforehand, then we can save this time. Okay, and the next thing is the order in which we try for deletion doesn't matter, as I already mentioned that. So in this case 5544, whatever order we follow, we know that the final answer that we will get is 2 3 4 5 only. It's not necessary that the characters which are repeated only that need to be deleted. We can delete other characters as well. Just what we need to do is we have to make a unique frequency of each character. So for example, we can make this 4 to 2, this 4 to 3, this 5 to 4, and this 5 to be unchanged. So here if you see, we change all of these three numbers, right? So here we are not waiting for the number to get it repeated. Just what we need to do is make sure that the final set of answer that we get has to be unique, and we do the minimum number of deletion. That's it. So considering these 2 points together, what we can think of is we have to somehow know that till what point it will be decremented. So what we can do here is sort this array in decreasing order and take one variable which says that max available number. So max available number will say that what is the number available which we can replace this current frequency with if there is a repetition. So how we know that if there is a repetition or not? So see, what will happen here is we have only option to decrease the number. We can't increase the number. So if you process the array in decreasing way, so if let's say a number 5 is there which is repeated and we replace this number with 3, then of course there is no space before this. So the next number, if it will be repeated, will again be replaced by any number which will be smaller than 3. Right. So what we can do is we'll start with maximum available number with the size of array, because assume that there is no available space in the current array. And now how to know that whether we need to replace this number or not, where there is a available space to replace it. So what we can do is here I'll take the same example 5 5 4 4 only, and I start with maximum available number. In this case is 10 plus 8, which is 18. And now I'm processing this in decreasing order. So till here this number comes 5. What does it mean? It means that this is the maximum number. So if next time if there is any available space, what it would be? It will be 4, right? Because if 5 is there, any number we can't increase, we can only decrease, the available number will be 4. Will be the current frequency minus 1. Now reach out to be here. And now see if the frequency of the number is greater than 4. What does this mean? This means that this number need to be replaced, because we started with max available number which says that there is no available space in the current array, and now this frequency is greater than this number. It means that we have to replace this number. So I wanted to say one thing here. So now available number is 4 and the current frequency is 5, which is, so here the frequency of current number is greater than available number. So it says that we have to replace this number. Why? Reason being, the frequency we are currently looking at is not at all available. The max available number is over here. In this case is 4, but if you are talking about current frequency 5, it means that 5 is not at all available, right? Because it has been used. That's why it's not available. So we have to replace this number. To what number will replace? We can only decrease it. What is the maximum available number? 4. So this will be up to 4. What is the number of deletion over here? Now again, and if 4 is being used, then what will be the next available number? 3. Now reach out to be 4. Again, 4 is greater than 3, which means that 4 is not at all available. It means it has already been used. If you see that here, it's been used. So what we can do is, we have to replace this number with what number? With 3 only. What is the next available number? Which is 2. Then reach out to be here, and here it takes one deletion. Now reach out to be 4. From 4, which is greater than 2, what does it mean? 4 is not available. We have to replace with some number. What would be that number? Which is 2. What is the number of deletion? 2. So total number of deletion comes out to be 4. And the final number will be, comes out to be 5, 4, 3 and 2. Right. Now let's think about the time and space complexity in this approach. Let's think about time complexity. So here what we are doing is, first step is thing, we are storing the number, we are traversing the given string, storing the frequency in some array, then sorting. So what would be the size of that array? K, right? And sorting that would take k log k. And first step was taking n plus. Next we are traversing this frequency array, and as each frequency we know that what number it has to replace. So it's take O of k time. So in this case, the time complexity would be O of n plus k log k, where k log k is the sorting. So here space complexity would be, we are taking one extra array to store the frequency of size k, which is fine. So one thing I wanted to point out here is, in all as per given in the question, we have only lowercase character allowed. So k, value of k would be 26. So in all the solution, if you look at, there is n plus something k square, or k square log k, or n plus k log k, something like that. So we can consider this part as a constant because k is only 26. In this case, all the solution would be, comes out to be linear. Let me quickly show you my approach. So here I implemented this third approach. Here what I am doing is, I created one frequency array of 26 because we have only lowercase character, then updated the frequency, sorted it. This will by default sort in increasing order, then I'll process in a reverse order such that we process in a decreasing order. So what we are doing here is, if the frequency is greater than the max available number, we know that how much it has to decrease. We add that to the number of deletion, which is the result here. And if it is not, then we'll replace this max available with frequency minus 1. Because if in that case, like, we visit the first number, which is 5, which means that the next number which we can use is 4 only. So that's where this comes. And why this is needed, because let's assume if there is a array where all the characters are unique, all the characters are 111, let's say, okay, then you know that to make it unique, you have to delete n-1 character, right? Because one frequency could be of only one character. Then max available number, we start with some max number, which is n, and then we'll update over here, which will becomes like 0 because the max frequency was 1. So if it becomes 0 for the next frequency, which is 1 again, so 1 minus 0 comes out to be 1. It means that the character will be deleted. And if you directly do max available number minus, then it becomes negative, and then again you will be doing negative, but frequency minus this will again be keep on increasing, and it will give the wrong result. So for that, to save this available number would not be less than 0. And why 0 is used multiple times, because we can delete any number of characters to make it 0, because it's not that we can delete, let's say, frequency of A and B, both are 2 and 2, so we can delete both of them to make it 0, right? So 0 can be reused, but other numbers like 1, 2, 3 cannot be used, because 0 is not like a fixed number. It's like that character is already been deleted. So in this question, we have to find the frequency has to be unique if character exists. Frequency of 0 means what? Character doesn't exist, right? Okay. I think it's done. Okay, thanks for watching. If there is any query or suggestion, please add into the comment section.